my intention here is just to show you how fast you should be. The results of the post-assessment were mixed. So I'll cover some of those here, but let's just go step by step. We have this f of x, and we want to find f prime of x, and most of you were great on this. F prime of x, bring the power down, 3 times 3x plus 4 squared, take the derivative of what's inside, times 3. And rearranging terms, and like I said, most of you did this, is 9 times 3x plus 4 squared. Okay, what about this one? This was, if you can't see it, this is the square root of x minus x raised to the third, and I want to find the derivative of that. Well, again, a lot of you did this great. I was so happy. Bring the power down, square root of x minus x, reduce the power by 1, take the derivative of what's inside, so we're looking at the derivative of this, right? And the derivative of that, well, x to the 1/2, bring the, again, just the power rule, and then derivative of negative x is negative 1. And you can simplify this, and I'll do that. This is, and don't distribute this, don't be in a rush to distribute this 3, right? Because even if you distribute it in here, it wouldn't really make things much easier. 3 root x minus x squared, and this is 1 over 2 root x minus 1. Okay, what about this one? Here we have a product of two functions. We have x sine of x cubed, and this one also, people, most of you nailed it. This is the first, x times the derivative of the second, which I'm just going to write sine of x cubed prime, because that's going to be the doozy, plus sine of x cubed times the derivative of x, which is 1. So what about taking that derivative? That's x times, well, what's it here? This is a composite function. We're cubing x, and then we're taking the sine of that. So we have to take the derivative of the sine, which is cosine, it's still x cubed, times the derivative of what's inside. That's times 3x squared plus sine of x cubed. And like I said, most of you just totally got this. You look at these two terms right here, and you get 3x cubed cosine x cubed plus sine x cubed. Perfect. What about this one? So remember, the differential operator preserves equality. There's the operator right there. So if we take the derivative with respect to x of y cubed, which is an implicit function of x, minus 4xy plus x cubed, and that has to be the equal to the derivative with respect to x of 1, because the differential operator preserves equality. So this is going to be chain rule, product rule, etc. So this right here is 3y squared times the derivative of y. That's the chain rule. And then we're going to have the product rule on this guy here, right here. So first we'll take the constant out, minus 4, and we're just going to take the derivative of x times y. Not a lot of you were thrown by this, which was really cool. That's the first times the derivative of the second, plus the second times the derivative of the first, which is just 1, plus, right, so we still have to take the derivative of x cubed, that's 3x squared, is equal to derivative of x the derivative of 1 with respect to x is 0. Okay, so now we are focused, laser focused on that y prime, and we are totally nervous about forgetting to distribute this negative 4 over both of these terms. So let's not be scared. This is 3y squared y prime minus 4xy prime minus 4y plus 3x squared is equal to 0. What did I say our laser focuses on? That y prime right there. So I'm going to do two steps at once. I'm going to factor out this y prime. y prime times 3y squared minus 4x. Okay, so that's these two terms. Let's use green. These two terms, I've just changed them into that. And we're going to bring the 4y plus 3x squared to the other side equals, but when we bring it to the other side we have to change the sign, right? Because we're really adding them to both sides. 4y minus 3x squared. Last step, divide by 3y squared minus 4x. Divide by 3y squared minus 4x. And we are done with finding y prime. There's our answer right there. So what did I ask for next? Let's fill this in here. All I asked for was the equation of the line normal to the curve at 0, 1. Well, from this equation we can find the slope. A lot of you just gave me the slope of the normal line. Others didn't evaluate this right. But y prime, we're asking at 0, 1. So this is how you can think about it. And this is the mental math part. Remember, this is x, and this is y. So look at that, 3x squared. Boom, 0, right? Because we're at x equals 0. Negative 4x, well, that's also 0. Boom. So now we just have to put y equals 1 in there. 4 times 1 is 4. 3 times 1 squared is 3. So the derivative of the tangent is 4/3. So the slope of the normal at that point is equal to negative 3/4. And we're pretty much done because we have a point right there and a slope. So we have y minus 1 is equal to 3/4 times x minus 0. So this would be perfectly acceptable, or y is equal to negative 3/4. Negative 3/4 x plus 1. And if you look at the picture, this would kind of make sense. Okay, that's it. Hopefully I showed you how fast it can be done, and maybe some of the mental things that should be going through your brain.